Every single developer, every architect, every team, we all face this moment. You've got a brand new project, a totally blank canvas. And right at the start, you have to make this huge decision that's going to define everything that comes next. Which architectural path do you take? Get it right, and you've set yourself up for success. But get it wrong? Oh man, you could be fighting your own system for years. So in this explainer, we're going to map out that journey, how to make that choice with confidence.
So here's how we're going to tackle this. We've broken the journey down into 5 key parts. We'll kick things off with the single most important decision you have to make. Then we'll explore the 2 big paths that open up from there, the monoliths and the distributed architectures. After that, we'll get practical and walk through a framework for actually making the right choice. And we'll wrap it all up with what I think is the most important mindset for any architect to have.
All right, so where do we even begin? Well, it's not with picking a shiny new technology, no. It starts with understanding one single foundational concept that's going to act like a compass for this entire journey. We've got to find our system's quantum.
So yeah, this is the question, right? It can feel pretty overwhelming because there are just so many options out there. But the trick to finding the answer isn't to start looking at frameworks and tech. It's about really, truly understanding one key principle first.
And that principle is this: the architecture quantum. Now, I know, that sounds super academic and complicated. Just stick with me for a second. Because this one definition, it's the key that unlocks absolutely everything. It's an independently deployable artifact with high functional cohesion and synchronous connascence. Okay, let's actually unpack what that really means in plain English. So let's just break this down. Independently deployable. That's easy enough, right? It just means the thing can run all by itself. It has all its parts. High functional cohesion just means it's focused on doing one job, and doing that one job really well. But this last one, synchronous connascence, now this is the really critical part. It basically means that if different parts of your system have to call each other and wait for a response, they are stuck together. They're bound. They have to be available at the same time. They have to scale together. They are, for all practical purposes, part of the same quantum.
And boom, this one idea gives us the first major fork in the road for our journey. Do you need one quantum, or do you need a bunch of them? If your whole system can live happily with one single set of rules for things like scalability and availability, then you have a single quantum. That's the monolithic path. But what if one part of your system needs to scale like crazy, and another part needs rock-solid data integrity? Well, now you need different rules for different parts. You need multiple quanta. And that, my friends, is the distributed path.
Okay, so let's head down that first path, the monoliths. This is the realm of the single quantum. We're usually talking about one big deployment unit and a single shared database. And you know what? For a ton of projects, this is exactly the right place to start.
Now, even on this path, you've got choices. It is not a one-size-fits-all deal. If your main goal is just simplicity and keeping costs low, say for a startup or a simple app, the layered style is going to be your best friend. But monoliths can be really sophisticated too. If your problem is all about data moving through a series of steps, kind of like an assembly line, the pipeline architecture is a super clean and powerful option. And if you're building a platform that other people will build on top of, like an IDE or a web browser, the microkernel style is perfect. It gives you a stable core with extension points.
Let's just zero in on that layered style for a second, because it's pretty much the default for a reason. It organizes your code by its technical job. You've got your UI layer, your business logic layer, and your data layer. It's simple, everyone understands it, and it's perfect when you're trying to move fast and not break the bank. But what happens when your system's needs are more complex? What if one set of rules just isn't going to cut it? Well, that's when we have to venture down path number 2, the world of distributed architectures, the land of multiple quanta.
And oh man, this is where things get really, really interesting. Now we're talking about multiple services that have to talk to each other over a network. If you need modularity but you're not ready for the full-blown complexity of microservices, service-based is a fantastic pragmatic choice. Need your system to be incredibly responsive and elastic? Event-driven is where it's at. What if you're expecting massive, unpredictable spikes in traffic, like selling concert tickets? Space-based architecture was literally designed for that. And for systems that have to change and evolve at a crazy fast pace, the extreme decoupling you get from microservices is king.
Let's zoom in on that event-driven style for a minute, because it is a major shift in how you think about software. Instead of services calling each other directly and waiting around for an answer, they are completely decoupled. They just shout out into the void that something happened. That's an event. And then other services can choose to listen and react or not. It's all asynchronous. So picture this. The flow is actually beautiful in its simplicity. One service publishes an event, something like order placed. A message broker grabs it and holds onto it. Then, any number of other services, inventory, shipping, notifications, they can all pick up that same event and do their own thing, totally independently and all at the same time. That right there is where all the power comes from.
And the payoff for thinking this way? Oh, it's huge. In fact, if we were going to hand out star ratings for these architectures, the event-driven style would get top marks, a full 5 stars, for things like scalability, elasticity, and how well it can evolve over time. That ability to process tons of stuff in parallel and totally decouple services is what earns it those high scores.
Okay. So we've explored the 2 main paths and a bunch of the styles inside them. But how in the world do you actually choose? It's not about just picking your favorite. It's about a methodical analysis. Let's walk through the 3 key steps you need to take.
First, you analyze the isomorphism. That's a really fancy word, but all it means is you try to match the shape of the architecture to the shape of your problem. If your problem looks like an assembly line, a pipeline architecture might be the right shape. Simple. Second, you have to evaluate that classic trade-off, scalability versus cost. Because let's be real, more scale almost always means more complexity, which means more money. And third, you have to figure out your transaction needs. And this one's a huge decider.
And this slide really gets to the heart of that third point. Do you need ACID transactions? That means your data has to be perfectly 100% consistent immediately after any operation. If the answer is yes, you're probably looking at monolithic or service-based styles. Or can your system handle eventual consistency, where things might be a little out of sync for a moment, but they'll all catch up eventually? If that's okay, then the whole world of microservices and event-driven architectures opens right up for you.
And this brings us to the final, and honestly, maybe the most important part of this whole journey. It's about a shift in your mindset, something every great architect has to do. It's about letting go of the idea of perfection and learning to embrace the trade-off. I really want you to let this one sink in. Maybe even say it out loud. There is no best architecture. There are only trade-offs. Every single choice you make, every single one, will make one thing better at the expense of something else. High scalability costs you in complexity. High consistency costs you in performance. This is the fundamental, inescapable law of software architecture.
So here's the deal. Your job is not to find some magical, perfect, best architecture that doesn't exist. Your real job is to find the least worst one, the one that gives you what you absolutely critically need while leaving you at downsides that you and your team can actually live with and manage. That's not compromise, that's strategy.
And just one last super practical piece of advice before we go. Once you've made that choice, you have to write it down. Use something called an Architecture Decision Record, or ADR. And please remember this. The people who come after you, or even you 6 months from now, they're going to care way less about how you built it and way more about why you chose to build it that way. The why is everything.
So, as we wrap up, I just want to leave you with this final thought. Look, it's easy to pick a technology because it's new, or it's popular, or it's what everyone's talking about. It's much harder, and way more important, to choose an architecture based on a deep understanding of what you're giving up. So the next time you're starting that journey, ask yourself this. You've picked your architecture, but can you defend the why?